today's world, most of the data are semi-structured or unstructured. To cope up with those data, we need to use machine learning concepts. And the machine learning are divided into three parts: supervised learning, unsupervised learning, and reinforcement learning. In today's tutorial, we will discuss about linear regression, which comes under supervised learning.
Okay, as usual, the roadmap, we are in the predictive modeling, week 1 of the 5-week session, right? Usually what happens is, like, after the advanced stats, this predictive modeling will be there. Now I don't know what was the reason they have put the data mining before the predictive modeling. Anyway, that doesn't make a lot of disturbance, but still, the order, we may forget the R squared, what is the correlation. So I'll give a small recap, what is a correlation, what is R squared, and then we'll keep going with the session. Right. Learning objective of this module, the total module, this predictive analytics, right? The linear regression, the logistic regression, linear discriminant analysis. All right. Learning objective of this session is going to be what is a simple linear regression and what is a multiple linear regression. These are the two main objectives for this session. All right. So I will have a pop quiz as usual. So what is the equation for a simple linear regression?
Y equal to mx plus c.
Y is equal to mx plus c. Now I have a different question. Okay, let me first write it down. Y is equal to mx plus c. Here, you mean to say the y is the c is the
intercept on y-axis.
Is the intercept, right? This m is the, what is m here?
Slope.
The slope, or you can call the coefficient of x, right? Now what is y here? What is the y here? Dependent variable, or what you could call it as, it is a predicted value of y for observation I. You have to put always yi and the y cap. Therefore, whenever you have to tell a simple linear regression equation, it is always starts with yi, y cap is equal to mx plus c, or you can put mi xi. Since it is a simple linear regression, okay, you can mention it as y is equal to y cap is equal to mx plus c. So now someone asks you, what is a simple linear regression model? Now I'm going to ask you, what is a simple linear regression model? How does it vary? So the simple linear regression model is given by capital yi is equal to b naught plus b1 xi plus e, the error term. This is very, very important to note, guys. So whenever we mention about the prediction, we give it as y cap and there is no error term here. When you are going to tell for the population, you must always present it in the Greek letters, that beta, e, and instead of e we can put it as epsilon I. So what am I trying to tell here is, if I have an x and y axis, right, and this is a linear line, let me change the color. For b naught, for a unit change in x, what is the unit change in y? This is x-axis, this is y-axis. For one unit change in x, delta x, what is a unit change in y? Delta y, right? So when we are asked for a simple linear equation, y cap is equal to mx plus c. I think it was also mentioned in your video. We should always mention it as y cap. Why? Because predicted value of y for an observation I. For I observation, what is your prediction? What are you going to predict? That is why you are always going to mention it as y cap. Right? So here you are not predicting anything. y-intercept. So this is what you call it as dependent variable. Here we call it as a dependent variable. This is also a dependent variable, but this is a prediction value of y. You do not have the actual y. So whenever we want to write a linear regression, you mention it as y cap is equal to mx plus x. Vijay, is it all right?
Yes, sir.
So for one unit change in x, what is the unit change in y? That is the prime concept of this simple linear regression. For that matter, regression itself. Even in logistic regression, we'll be solving the same thing for a unit change in x. What is the unit change in y? That is what we are going to find it as part of your regression model. Right? Our second question comes is, can we have more than two independent variables in simple linear regression? Can we have more than two independent variables in simple linear regression?
No.
Okay. Why no?
Because that will be multivariate.
Yeah.
That becomes a multiple linear regression. Right? Now, the second question, what is the equation for a multiple linear regression?
Y cap is equal to m1 x1 plus m2 x2 plus m3.
Perfect. Y cap is equal to m1 is also good, b naught plus b1 x1 plus b2 x2. All right. You mention that Greek letters beta, epsilon, odd for population. This is what we are going to predict. So we always use B, the alphabets. So in our beginning of the statistics class, I always used to mention. So beta, the Greek letters always used to mention for the population and the alphabets for the sample. All right. This multiple regression is just an extension of this OLS, ordinary least square regression. Right. What is that ordinary least square? That involves more than one explanatory variable. More than one explanatory variable we have, then we call it as a multiple linear regression. Right. Now name few techniques to deal with multicollinearity in the data. How to deal in multicollinearity in the data?
Principal component analysis.
Okay, how do you identify whether there is multiple collinearity in the data? Whether there is multicollinearity in the data?
There is a correlation between big correlation between two independent variables.
Correlation between two independent variables. All right. So, so any other option? In regression, what happens is when we try to run a regression, none of the coefficients become significant. It leads to a question whether there is multicollinearity in the data. When I'm trying to run a linear regression, if none of the coefficients are significant, I hope you know what is significant, right? Based on the p-value in the overall table, based on the coefficients value, you arrive at the p-value, right? So none of the coefficients become significant, then there is a presence of multicollinearity in the data. You have to recheck that. Next, one more important concept is VIF, variance inflation factor. Variance inflation factor. There's not part of this scope of this session. Probably next session or the other session we'll be discussing what is VAF. But roughly I'll tell you what is VAF. VAF is given by the formula 1 divided by 1 minus R squared. What is R squared?
Correlation coefficient, covariance coefficient.
Coefficient of determination. We call it as a coefficient of determination. Right? What does R squared try to tell? It measures the proportion of the variation in Y that is explained by the independent variable X. Some variance present in Y. Some variation is present. How much is my predictor X variables, the independent variables, is able to explain it? That is called as an R squared. we are going to predict y, right? End of the day. So how much y, prediction of y is able to do by my x variables. That is what we call it as an R square, right? So if it is by default thumb rule, we'll have it as 5. It is nothing but if you have 80% R squared, right, you'll get an VAF value of 5. If a value more than 5, we call it as a highly correlated, the presence of multicollinearity in the data. We'll see that in detail in the next session, right? And one more thing which I wanted to tell here was, so here I mentioned the explanation by the regression, right? How much variation in y is able to explain by the variable x. Let us check it out, how it is. So in the x and y axis, I draw a linear line. So there I'm going to predict a value, or 1 second, let me make the axis bigger. This I call it as x-axis. This I call it as y-axis. All right. So in the total sum of squares, this is called as total sum of squares. In the total sum of squares, how much is my regression able to explain? Sorry, up to this it comes. Regression. We call it as regression sum of squares. And how much is my unexplained variance? What do you call it as unexplained as? What do you call the unexplained variance in the total regression, the total sum of squares?
Sum of squared error.
We call it as error. Sum of squared error. Sum of square error. Perfect. The error is nothing but sum of square error. Sum of square. Yeah, sum of square error is correct. So in the total sum of squared error, how much is my regression able to explain? How much is my regression not able to explain? So I'll show you visually in Excel also how is this regression, how much regression is explaining, how much regression is not explaining it. Right? The regression is nothing but the independent variables, whatever I have taken, how much is it able to predict the variation in the variable y. I'll show you very clearly in Excel, and by the end of this session, you'll have very clear understanding about the regression concept, right? So in the simple linear regression, so here y is equal to b naught plus b1 x1 they have mentioned, but you can put it as y cap is equal to b1 b naught plus b1 x1. In the simple linear regression, it is when if it is more than one variable, right, we cannot explain it in the two axes. So we have an industry application. We have two industry application. One we'll see it, and after that we'll go to one case study, and then we'll have look on the one more industry application, and then we'll solve the second case study. So I'll make sure one is explained. We have 30 variables. At least I'll take 10 variables and I'll able to try to solve it in Excel and I'll show you. All right. Can somebody take a lead and read this question, the case study? Someone please, Vijay, if you could.
Industry application, linear regression in sports analytics. Sports analytics is a booming field. Owners, coaches, and fans are using statistical measures and models of all kinds to study the performance of players in the teams. Billy Bean, the manager of Oakland, has met Peter Brand, a young Yale economics graduate with radical ideas about how to assess players' values. Rather than relying on selectors' experience and intuition, Brand uses linear regression, selecting players based on their on base percentage (OBP) while ignoring their perceived weaknesses. Brand and Bean use this methodology to hire undervalued players. With 1/3 the budget, Billy Bean's team performed at par with the highest paid teams. This led to evolution of a new stream of analytics known as sabermetrics.
Sabermetrics. So I hope if someone has watched the film Moneyball, has anyone watched the film Moneyball?
Yes.
So it was just taken from that. So if you had known, right? So the sabermetrics, the term was formed only after this way of picking the players, right? On base percentage, OBP, right? So if you had watched the movie, they had very little budget to hire a number of players, right? So after big depression of the Auckland, the team, right? So he wanted to win the matches. So he used a different technique. So even certain players were hurt, and the base players were very less for them. So using his techniques and ideas, he has picked the players of very less price, and then still they were able to compete the overall the match. Right? So you could read this, what is cybernetics. I have given the reference. So if you have not watched the film, watch the film Moneyball. So it is very good. So how they have hired the players. Uh, so they've used the basis of this OBP was based on the linear regression. That's what they have used to pick the number of players. Let me go to the case study which I wanted to discuss now. The salary prediction. In an organization, salary of an employee depends upon various different factors. Right? Based on the given data, build a model using simple linear regression to predict the salary of an employee based upon the experience of the employee. Now I'll go to this. I have solved it. Anyway, we'll solve it new. So we have years of experience and salary. I'll put it in the new Excel sheet. So years of experience and salary. So as the years of experience increases, the salary will also increase. Is that true or not? So this is a linear variable. As the salary increases, the years of experience, as the years of experience increases, the salary of the person also increases. Now I want to predict a person, a new person, or say an HR in the company. A person comes with 5 years of experience and is asking a salary of 1 lakh, something abnormal, right? So you have to predict the right value. What is the apt salary to give to the person? It is based on the years of experience and the salary. So if you could plot, let me just try to plot here. As experience increases, the salary increases. Yeah, salary, and the salary increases. So if a person comes with 5 years of experience, so you could plot for 5 years what is the right value. He could ask something around 55,000 or 60,000. He's asking abnormal 1 lakh or 1.2 lakh, right? So in that way, we could predict. We want to predict apt way, right? We want to predict the right salary. How are we going to predict? We are going to use a simple linear regression to predict the years based on the years of experience. What is the right salary? Now I want to introduce a new term. Not I will not tell it as a new term. Now, what is the scope of this of the regression that we are going to build? We have an years of experience of the employees between 1.1 years and 10.5 years. So if any employee who comes to the company between this experience, only between this experience, I'll be able to predict the right salary, a predicted salary. If a person comes with 20 years of experience, my model fails. We have a point of diminishing returns. So if someone is from the MBA background, there is a point of diminishing returns. So in marketing, if I spend 1,000 rupees, I'm able to get a 2% increase in sales. Again, if I'm spending 2,000 rupees, my sales increases by 4%. Again, if I keep on increasing the 1,000 values for the marketing, my sales does not get increased. Right? There is a point of diminishing return. Beyond a point, if I'm spending 5,000 rupees, there is not going to be 10% increase in the sales. We call it as a point of diminishing returns. Similar, applying the same concept to our regression, my model will be able to predict a new person who comes only within experience of 1.1 to 10.5 years of experience. If someone comes between, if I do not have 8.5 here, if a person comes with an experience 8.5, I'll be able to predict what is the right salary for them. I'll be able to predict. If a person comes with 20 years of experience, my model fails. with 25, 15 years of experience, my model fails. Beyond a point, beyond a confidence interval of my regression, if a new data point comes, I will not be able to predict the right salary for the person. Is that clear, guys? Is that clear? Any
Yes.
doubt here?
Yes.
So we have a confidence interval. Only between the range that I have taken, I'll be able to do the prediction perfectly. Right? So it's very simple to do it in Excel. I select these two variables, go to data, data analysis, regression. V1. So for representation purpose, let me delete all these things, because if I start writing the formulas, so it will be very difficult. So data analysis. So I have taken only the, I'll delete it. This one I tried it. The Y variable is the salary, and the X is the years of experience. And I'm going to pick the labels here, right? And I want to show the value. So in very simple way, I'm able to use option regression in Excel, and I'm able to come up with the R squared values, the adjusted R squared values. So standard error, right? So the total adjusted R square was something around 90%. Right here, just for representation, since I taken it showing 69%. Now we'll see each and every variable how to solve it using the formula. Right? It's very simple, but you should know how an R squared is derived, how an adjusted R squared is derived, and how an standard error is derived, right? How an B0 B1 is derived, right? So you have given me an value y cap y bar is equal to B0, where is B0, plus B1 x1. This is the formula you have given me. Now my prediction comes between like a person with 2.5 years of experience. What is the salary? This is my objective. Let me place the objective at the beginning of the session, beginning of solving this question. For the 5 years of experience, what is the apt salary? Even though the data points are very less, this model is not a perfect model, but still, just for explaining purpose, I have taken. Right? In the real data, I have around 30 data points, which will be sufficient to explain. Right? I have solved it for all the 30 points. Now, what happens is, like, I have to go down, I have to show you what is it and how to do it. So I'm taking only the 10 points. Is that okay, guys? All right.
Yes,
So,
sir.
and one more objective here is to learn what is MSE, RMSE, MAPE, like our sensitivity value, the specificity value, and the precision recall, the accuracy in classification problems. Now we start solving in regression problem, a continuous value. So for continuous value, you cannot put the values in the confusion matrix. So you have to use a metrics such as MSE, RMSE, MAPE. Right? I told you a lot time. Before time, we'll be solving. When we come to the predictive analytics, I'll explain you what is MSE, RMSE, and MAPE. So only if I solve it using the formula, you will have a better understanding what is MSE, mean squared error. So let me just add a couple of cells here. I'm taking an average value of my X variable and an average of Y variable. Right? Average of Y variable. Now I want to predict yi minus y bar, right? Yi is nothing but this variable, minus y bar is nothing but the average. Give f4 is like locking the variable. So I'm just copy pasting the formula to all the cells. So what happens? The negative signs are present here. To overcome the negative signs, I'm just taking the square value of this yi minus y bar. Similar to ANOVA problem that we had solved. Similar to how to find an variance and standard deviation. It's all again the same formula. Right? I'm just taking the square value of all the variables that I have found here. yi minus y bar. Right? Let me just put in box over here. Now next is xi minus x bar, xi minus x bar, and xi minus x bar the whole square to overcome the negative sign, right? Again xi minus x bar, I'm just fixing it, and I'm taking the square of all these values. Alright, so I'll use the same box over here. Now I want to find xi minus x bar into yi minus y bar, right? So xi minus x bar, we have solved it into yi minus y bar. So I have a value, right? So I'm taking the average of all these values and average of all these values. So it may confuse you. I'll just explain you in detail how to solve this again. And now our objective is to solve what is B1, what is B0, right? If I know what is B0 and B1, I have y value here. Sorry, I have to find the y value here. Here, if I know the B0 and B1, I could put the values over here and I could find my y bar. What is the y value for the years of experience? 2.5. Is that right, guys? Is there any confusion here so far? So my objective is to find B1 and B0, right? If I could find B1 and B0, I could impute in this formula and I could come up what is the predicted value. Now I have a value B1. How to find B1? B1 is given by this divided by the total x1 minus x bar the whole square. So I have found a value B1, right? And B0 is given by, so I have this y formula here, then B0 is given by y bar minus B1 x1. Alright, so I want to find the B0 here is equal to, what is the y bar here? I'm taking the overall average minus, what is B1 here? B1 into x1. So I found two important variable, what is B1 and B0. So if I had found what is B1 and B0, I could impute for the new variable, for the variable 2.5, B0 plus B1 into x1. What is the value? His predicted salary is around 51,590. Guys, I am seeing a lot of silence here. So do you have any doubt here or shall I keep going? Or do you want to be precise only in Python?
Sir, can you explain it once more?
Yeah, all right. So how did I find B0, B1, or what do you want me to explain?
No, just like for some just to summarize.
All right, I'll summarize.
Yeah.
So I'm taking yi minus y bar the whole square. The y bar is given by the average value. To overcome the negative values, I have taken the square of the yi minus y bar. So I will get in values. Again, xi minus x bar. This is also to overcome the negative values. I use the formula xi minus x bar. Here I will put it as x bar. Alright, so xi minus x bar into yi minus y bar. This is used to find a variable b1. So to find b1, the coefficient of x1, you have to divide this value by this value.
Okay. Okay.
All right. So don't get too much complicated. We are not going to use this in the real time. So I wanted to show you what is MSc, RMSc, and MAP. On the way, I myself created an objective. What could be an predicted value for the years of experience 2.5? What could be the salary for the same? Now my objective, one more objective. This objective I have solved. What for the years of experience 2.5? What is the salary? Now I want to find how good is my model. How good is my model? How good is my model is explained by MSc, RMSc, MAPE. Now, how good is my model is explained by Y predict value. Y predict.
Sir, sorry to interrupt. Just 1 second. The initial equation y bar is equal to b naught plus b1 into x bar. It should be x bar, right?
This one here. Here I have okay. This we can put it as
b1 star x bar, right?
b1.
Because
no. I'll tell you. No.
Go
This is going to be x1 only. Why? See, for or no, it is not one. I'll put it as I, bi and xi, because I'll tell you why. In the y predict, I want to predict the value of y. This is the actual, right? This salary is nothing but y actual. Now I'm going to predict y here. How am I going to predict y? Using this formula b naught plus b1 into x1. So this is the actual, this is the predicted. So this applies for all the records here. So how will I put it as x bar? So
you imputed this while calculating b0.
Okay.
You used y bar and x bar.
So you want no. See, to find the coefficient, I do not have any other metrics other than taking the average. So this b0 and b1 is taken by the overall average.
Yeah, got it, sir. So the second equation b0 is equal to y bar minus b1 into x bar.
Okay, this one you want me to. So the terms. Okay. Even your question is even more precise. Wait. What you're trying to ask is if you're going to put x bar here, why not x bar here?
Correct. So instead of y bar, we should write y cap or something.
Yeah, this is actually y cap. That's what I wanted to put.
Yeah.
Sir, I have a question.
Yes.
So
Yes.
BI, in our case, BI is constant, right? We have just calculated B1 and we are using it everywhere. So it will not be BI, correct?
It should be B1, yes.
This is B1, sorry. This is B1. Oh, the big problem, what I tried. Okay. See, here, what did I put? Here, the formula, what I have written is, it is Y cap. So, since I was not able to mention it as Y cap, I put it as Y bar. This is actually Y cap.
Yes.
So what? 1 second. If I go back here, it is Y cap. So I wanted to represent it as Y cap. Instead of that, by mistake, I put it as Y bar. This is X1. I'll put it as X1. Right here, why it is X bar. I do not have any other metric to find the overall coefficient. This applies for all the records. So I cannot take it only xi here, x1 here. So I'm taking the average of all the values to find the value, the coefficient b0 and b1. Here I should always take only the average. I should not take any one record. Sagar, am I confusing you or Monica? Sagar and Monica, are you clear? Am I able to convince you or is it still?
So we almost got it, but here, yeah, in this formula, so x1 will not be a constant, right? It will be xi because we are predicting a y cap, correct?
Yes.
But b1 and b0 we are using as constant.
B0 and B1 is always constant. Okay. I'll put it as
Yeah.
So actually when we write in linear regression formula, we'll write it as BI into XI.
Okay.
So
So, but there we
B,
have that assumption that the slope is not changing. So we use a
it does
constant.
not change. It does not change.
Okay, got it.
So here again, if you want to predict the prediction of y, it is given by b naught plus the b1. The slope is always same into the xi. So this is the actual. The actual it is predicting as 46,205, but my prediction is giving me only 39,351. My model is poor model here, like I said before, because the records are very less, but still just for representation and understanding the formula how to solve the y-pred, I have taken it. Again, I'll just fix these values. B0 and B1 I'm not changing. So the values, the overall values, using the formula, using this B0 and B1, I'm able to give the value y-pred. Now I have to find what is the error. The error is given by y minus y-pred, y actual. So to be more precise, y actual minus y predict. I think I'll be able to answer you this both question at last, or while summarizing, I'll be able to tell you. Right right now, you just concentrate. How am I calculating this error? Error is given by the actual minus the predicted. So wherever you go, actual minus predicted, I'm calculating the error. To overcome this negative value, again, error whole squared, error whole squared, I'm able to find it. The average of all these errors, I call it as mean MSE, mean squared error, mean square error, right? So this is of a different scale. I have to make it an RMSE. If I take RMSE, it is a root mean squared error. Since I have squared it over here, I want to bring it in the same units of this y variable. I want to bring it in the same units. That's the reason I'm taking it as square root of MSE. I get the value RMSE. So these both metrics are very important. And one more important metric which I wanted to tell you, this is not the part of the scope of this session, but still, since I have covered this MSE and RMSE, I wanted to cover this MAPE also, mean absolute percentage error. How do I calculate the mean absolute percentage error? Error percentage absolute mean, always remember it in the reverse way. We'll be solving it many times throughout the session, but still, first the error is given by the error divided by, I'm sorry, so absolute, first of all, absolute error divided by the actual. All right, so I'm taking the values for all. Now I'm taking the average of all these values and I convert this to a percentage scale. So then I call this value as a mean absolute percentage. So this is a different metric. In time series, throughout time series session, we'll be solving this MAP. This is a different metric altogether. MAPE. MAE again, mean absolute error. I have taken the percentage, mean absolute percentage error. So important thing to note here is I have taken the error y actual minus y predict and I have solved the mean squared error. Right? If I take the square root of it, I get the root mean squared error. For a new value which comes between the range of 1.1 to 3.2, what is the predicted salary? With the values of B1 and B0, I'm able to predict what is the salary for it. Now, how did I solve this B1? B1, I have found it by xi minus x bar into yi minus y bar. I have found divided by xi minus x bar the whole square, right? So to give, again I made a mistake by y bar, mentioning it as y bar. Here it is y cap, or just for simplicity you mention it as y also. Y is equal to b naught plus b1 into x1. Now to predict this b naught, I have to take this b1 minus of b, what is the, I'm sorry, what did it, okay, the average of all the y value minus this b1 into the average of all the x, I'm sorry guys, average of all the x values. Are you able to understand this two part? If I'm not confusing you, do you want once more? Monica, Sagar, is it clear this part?
Yeah, somewhat, sir.
Somewhat. Okay. So in this formula, I do not know what is b naught value. So I'm just keeping this b naught here, and I'm taking this b1 x1 value to the other side. Right. So whenever I want to find this b naught, it is a comprehensive measure for all the records. So since I am taking all the records, this y value is taken as an average of all the x values minus of b1 way I know, and average of all the y records. So it is always given by average of all the x values and average of all the y values. Don't confuse this with this.
There was one sentence which was told in the video that best fit line will always go through x bar comma y bar.
Okay.
So I think that is because you are calculating b1 and b0 using x bar and y bar.
X bar and y bar. Yes, yes.
Yeah. Okay. Yeah. Now I am clear.
Right. Maybe this formula is confusing you. If there is no formula, I think you will be more clear. So I just confused you with this formula. Y cap minus, I'm just taking this b1 and x1 to other side. What happens? b1 into x1. So do not confuse this x1 and y cap. This y value is summarizing all these values. So I'm taking only the average value. The x values, I'm taking the average of all the x values to find the b naught. It is a best value of this b1 and x1 under without any other condition. I'm considering this is the best line. The average of y values and average of x values is the best line. So I'm taking the average of the x and y value to find the intercept b naught. Right. So, and one more important thing what I have told you is the error, how to find the MSE and RMSE. All right. So going back here, so the multiple R squared, how am I going to find the multiple R squared? Multiple R squared is nothing but is given by the correlation between the x comma y. Correlation between x comma y is given by the multiple R squared. So what is R squared? How do I calculate the R squared? R squared is always given by how much did my regression explain of the total. So that's how I calculate the R squared. Right here it is all solving. The Excel has an inbuilt function to solve it, right? But still you should know what is an R squared, how is it solving of the total regression and residual. How much did my regression able to explain? What is the adjusted R squared? It is calculated based on the degrees of freedom. Degrees of freedom of regression I want to find. So what is the difference between this adjusted R squared and R squared? So I think it was all explained in the video. What is the difference between this R squared and adjusted R squared?
It does not consider the non-significant independent variables. For example, there is a population data, and there is one variable which is not contributing for the dependent variable. But while drawing the samples, drawing the sample from that population, there is some contribution shown by that independent variable.
Based on the independent variable. So what to put it in simple terms, R squared, I'm just calculating how much did my regression explain, like what you explained, right? They adjusted R squared based on the number of values, based on the number of records. Records should also be considered here. The degrees of freedom is also very important to be considered. Considering the degrees of freedom, the number of independent variables, what is the apt value? So when for a simple linear regression, you may consider R squared. When you consider multiple linear regression, multiple number of x, many x values, many independent values are there, it's always right adjusted R squared is an apt value to consider whether my model is a good model or an is adjusted R squared is a good metric to identify whether is my model performing good. All right, how do I identify the adjusted R squared? Adjusted R squared is given by the, I'll put it over here, is given by 1 minus of, I'll put it in the reverse way, so I'll take it the residual sum of squares divided by the degrees of freedom, and the total sum of squares divided by the degrees of freedom. Since I want to identify the regression, 1 minus residual divided by the total sum of squares, right? That is how this adjusted R squared is calculated. What is the standard error? Standard error is nothing but the square root of this residual, square root of the mean square of the residual. I do not want to go again and explain this ANOVA table. It is going to take a lot of time. So what I'm trying to tell, we were able to solve each and every steps in Excel using the formula, right? We are able to cross compare and get the right values of the regression table in Excel, right? And we have solved this ANOVA table. I think you guys know how to solve it, right? This F significance F is nothing but the P value. So P is low, the null will go. So the regression model is worth executing, right? How? What does it signify? The salary is a good predictor to identify the years of. I'm sorry, the years of experience is a good predictor to identify the salary. So is this clear? I took an extra step to solve it in Excel. There are 2 case studies to be solved in Python. So that is the only objective of the session. So I wanted to show how an MSc and RMSc and how this B0 and B1 is calculated in Excel. So was it worth solving? How do you find? Is it confusing? Is it okay? Shall I go to Python?
Yes, sir, it was helpful.
All right. So okay. We'll see the same in Python. We have 2 case studies. One is Airbnb and all right. All right. This is the student solution. Now I'm importing the libraries NumPy, Seaborn, Pandas, and linear model. All these variables. Just importing it here. Just give me a moment. And the salary data, I'm just importing it. Head command showing me. So these are all the preliminary cases that we used to do. Describe gives me the summary of the years of experience, the total summary. So the mean value of the summary is 76,003. Why it is showing different? We have taken only 10 records in Excel to represent it, but here I've taken there are total of 30 records, right? So if I wanted to show the 30 records, it would be very much confusing. So I've taken only 10 records. So the standard deviation is 27,404 for the salary, right? The years of experience is the standard deviation is 2.8. To find the distribution, I use a command SNS pair plot to see the distribution. Here we could see that the data is linearly distributed, right? And the correlation plot, here there is only one variable, so it is highly correlated. So is this correlation good or bad? Is this correlation good or bad?
It will be good.
Bad.
It is good.
Why?
Close to 1.
Okay, close to 1. So is it in multicollinear data or?
This is simple linear regression, so this correlation is good.
This is good. Actually, we are finding the correlation between the independent variable and the dependent variable. So always the correlation between the independent and variable and the dependent variable must be very high. Only then that it shows that it is a very good predictor to find the y variable. Here it is a very good predictor, right? So so any doubt here, guys? Any doubt? So why it is high correlation y problem? Monica, Sagar, any doubt?
No doubt, sir. I'm good.
Okay. So the train test split. So we have seen it number of times. We use sklearn model selection. From the model selection, train test split. Right now, there are two options to find the linear model. Right, one from the stats library and one from the scikit-learn. Right. Let's first start how to do it in the scikit-learn library. Always in this sklearn, we must identify what is the we must give an object name for the function linear regression. Linear regression. I'm just referring it as regression model. Regression model. So in the regression model, as a segment, regression model, what am I trying to do? I'm trying to fit the values between what? NP. I'm converting this as an array because that was not in an array. X train, and this all is given because the from the data frame we have extracted only this X train, right? So what happens is like it converts from a vector to the data frame to a vector. So I'm just converting back to an array. Reshape 20,1. How many? 30% is like 21 will be. And Y train. So we have fit the model, regression model for the X value, the train and the Y train. You forget this reshape and the NP array. I'm just converting it to array because what happens is when I was splitting this X and Y, so when I was trying to fit this X and Y from the data frame, since it had only 2 columns, it is just converting it as a vector. So there's some error was coming. So I'm converting it as an array and I'm reshaping it as 20,21.
So, sir, this step will be required only when we are doing simple linear regression because we will have only one.
So that that may be required. Yes.
Okay.
I'll show you why did I use it. So okay.
Yeah, I got the same error, so I had that question today.
Okay. So if you could see why test, right? It was not in an array. So if you could from the numpy, you use an array. So this was the workaround. I'm converting it as an array and I'm converting it as reshape to how much is 1, 2, 3, 10, 1. So I'm just converting it to an array. So that's how the input is taken for this linear model. That was the reason I've used this NP array. Okay, that is nothing to confuse. So now what is the coefficient of the model that I have built? Right now in the regression model, I want to find what is the coefficient of 0. It gives me what is it trying to tell me? The coefficient, 1 second guys. Regression model dot coefficient is always given in the 0. Right, 1 second. Alright. Therefore, the coefficient, that's correct only. So for the years of experience, so what is the coefficient for the years of experience? The coefficient for the years of experience is 9202. 1 unit increase in the year of experience, the salary increases by 9202. That is an important takeaway here. Straightforward in linear regression, you will be able to solve. 1 unit increase in the years of experience, how much the salary increases? It increases by 9202. Alright. So what does an intercept mean? What is an intercept from your understanding?
Where the slope cuts the y-axis, the line cuts the y-axis.
Okay, that's perfect. That's theoretically. What is philosophically? In generic terms, you tell me. Philosophically,
When,
what is that intercept trying to tell?
when all independent variables are zero, what is the output?
Perfect. What is the output? Intercept is containing the effect of all the omitted variables that we have not considered in the model. For example, if I have taken 3 or for example 10 independent variables, it's not everything. My y variable may be explained by the 11th variable. Why 11th independent variable? That is not considered in this model. My 10 independent variables together was able to explain only 80% of the variation. By addition of one more important variable, it could explain still 5 more percentage, 85% of the total variation in y can be explained by that 11th variable. So we could have missed out somewhere. So that missing effect will be taken in the intercept. Right? Intercept is containing the effect of all the omitted variables that we have not considered in the model. That is very important to tell. Right? Therefore, the intercept for this model, I have to find the intercept, right? Intercept is given by a regression model dot intercept. Yes. So the intercept is 26049. If my x is 0, what is the default salary? If my years of experience, a fresher comes, what could be the right salary? We could give 26,049 rupees, 49 units. I cannot tell it as rupees. So that's what the end takeaway from this regression. What is the R squared? How do you find the R squared? Again, to find the R squared, I use regression model dot score. Regression model score, again I'm using that NP array, all those things. NP array of X train, regression X train, and reshape to 21,1 and Y train. So 96% of the variation in Y is able to explain by this independent variable X, the years of experience. 96% it is able to explain to me. Right now in the test set, how much is it able to explain? The same X underscore test. Right. So here the length of X test, or you can put 9, the remaining variables, comma 1. So 92% it is able to explain to me. So if a new variable comes in, I could given confidence 96% and confidence with the area with the years of experience, 5 years of experience, this could be his salary, provided he is within the same confidence interval that I have taken to train the model. Else it comes the diminishing effects of the model. If I take beyond the range of the X variable that I have trained. Right now, option 2, using the stats model. Using the stats model, here a few things I have typed. I think this was the file which was given to you guys. I think this is the file that was uploaded in the Olympus. Right now, data train is equal to, I'm concatenating this P train, X train, and Y train. I'm making it the same again, same data frame. Right, and fit the OLS model, ordinary least squared model. How to fit the ordinary least squared model here? We import from stats model formula API, suppose, okay, as SMF. Some name, stats model, formula, API. We am just giving it as SMF. Does not matter whatever you give. It's just an alias name. Now I'm building a model, linear model 1. I'm going to give it as SMF1, ordinary least square regression. What does it mean? Formula is equal to salary. Salary is a function of years. One second. Okay, I could see here. Years experience. What is the data? Data is equal to data train. And I'm going to fit the model. Right? Now my model is fit. And what is my LM1 dot params if I'm going to give? What is the intercept value and what is the years of experience? The coefficient value. Intercept is 26,049 and the years of experience is 9202. If you have to use, if you, anybody have used the R, only this is the only way to solve the regression. We'll get even further more details in R in the stats model. Even here, only in the stats model, you'll get so many details. The adjusted R squared, F statistic, probability. But in the sklearn, you will not get, because this was developed by a statistician, that was developed by a programmer. So there is a primary difference. That's the reason we get more statistical information when I'm going to build a model using the stats model, right? So what does the end take away from here? If 1 unit increase in experience, the overall years of experience, the total salary will increase by 9,202. That is how my coefficient variable able to contribute. So is it clear here?
Yes.
Now, what is the null hypothesis?
Sir,
I'm sorry. Yeah.
Sir, could you please repeat the interpretation you just said?
1 unit increase in years of experience, the salary increases by 9,202.
Okay.
This so and so.
Okay, got it.
That is very important to note, right? That is coefficient of the x1 to predict y. 1 unit increase in years of experience. How much unit increase in the salary? That is the power of this regression. You cannot do it in any model. That 1 unit increase of which variable, how much it is contributing.
Sir,
yes.
If we compare it with our formula, this 9202 will become our B1, right? And
yes, B1.
26049 will be our B0, correct?
B0, yes.
Okay, got it.
B0 and B1. So, 1 second. Okay, here I try to solve this B0 and B1. Fine, anyway, I'll try to share this Excel to you. Here you could see 25,792 and 9,449 was my B1. Here it is 9,449. Here there is a subtle difference. I don't know what was the reason.
So because this is only the training set and there we have calculated for
perfect. So I have calculated all for all the records, for the all 30 records. Here, yeah. Here there are only 21 records has been considered. Yeah, thanks, Monica. So I'm trying to solve this B0 and B1 using the Excel also, right? So yes, I've taken only the train data. And when I'm trying to summarize all the model values, I get an adjusted R squared and I get an R squared. I get an F statistic, right? From F statistic from the ANOVA, what we have learned. So what is an F statistic?
P-value.
F statistic is not in p-value. The probability of F statistic may tell you in p-value.
Okay.
So F statistics based on the critical value, the sum of squared errors by the regression divided by the sum of squares, overall mean sum of squares. If you could remember the ANOVA days, right?
Yes.
We used to take the mean sum of squared regression divided by the mean sum of squared errors. So we get the F statistics. So if F statistics is greater than the F critical value, then it is a significant value. Right? Then we calculate AIC, BIC. AIC is nothing but Akaike information criterion. BIC is Bayesian information criterion. If your this is calculated based on the this log likelihood test. We'll see it AIC value in logistic regression. How are we going to see it? How are we calculating this AIC value? Right? In logistic regression, I will solve it because I don't want to weigh. We have one more case study to solve also. Right? So what we know here, adjusted R squared we have calculated. We have calculated based on the degrees of freedom. Right? And we know the intercept value over here, and we got the years of experience over here. Right? And we know the probability. It's typically it's not 0, it's 0.000, somewhere one or some value will be coming, right? It can never, the probability can never be 0 since we have taken only these 3 digits, so it is 0.000. All right. Now to calculate the MSE, so here you could see the MSE, the predicted value minus the actual value. The regression model predict, okay, see here, once we predict it, I'll get the predicted value minus this actual value, and I'm just squaring it up and I'm taking the mean. Everything, all the hard work that we have done it in Excel, in one single line I'm able to solve it. But you will not understand here. Once you get to pro, once you become a pro, then this becomes very easy. But for the learning purpose, you try to solve it in Excel once. My kind request, right? For all the 30 records, you please take it down and solve what is an MSE and what is an RMSE. How is an MAPE calculated, right? So these 3 metrics are very important. Even if you have to participate in hackathons, most of the times this MAPE value or the RMSE value will be considered for your that winning criteria, right? So why predict? Y actual minus predicted, you take the whole square and you take the overall average, it becomes mean squared error. I'm sorry, it becomes mean squared error, right? That's what I try to solve it in Python here, right? And I'm taking the square root, it becomes an RMSE. Why we need an extra metric? We have already an MSE. Why do you need an RMSE? This could be an interview question. So to bring it in the same unit of your variables, the y and x variables. Here it is y variable. So to bring it in the same unit of your y variable. Why do we take in square? To omit, to overcome the effect of the negative. A negative effect. Because if you sum it up, I'm going to take the average, mean squared error, right? If the second negative signs are there, then it may become a 0. Right? Again, the regression model predict is given by regression model predict of the overall. This is for the test data, right? So the test and the predicted value, how much it is differing. So that is how we solve this simple linear regression in this Python. So I could solve this in 5 minutes. So rest of the time you may not be able to understand. So what is MSE? How to solve it? So this Python gives an like formula kind of thing, right? It's kind of a coding kind of thing. You do not know how it is solved. So that was the reason I have taken a step to solve it in Excel. Now, how to solve this? Now let me go to. So do you have any doubt here, guys? On simple linear regression. Any doubt? Please question me.
No, sir.
No, sir.
Vijay, any doubt? Am I good to go?
Yes, sir.
All right. I have one more case study to solve. So the price prediction, Airbnb. So Airbnb Incorporation is an online marketplace for arranging or offering lodging, primarily homestays or tourism experiences. Airbnb has close to 150 million customers across the world. Price is the most important factor considered by the customer while making booking into a property. So these are the variables I have considered. ID, the room type, accommodates, how many number of people, the bathrooms, the cancellation policy, the cleaning fee, instant bookable. So these are the various variables that are present to predict what is the price, right? So now when we're going back to the strategic pricing of the properties is important to avoid losing customers to the competitors. So we have data of 74,000 odd numbers Airbnb properties across the nations. Based on this data, build a simple and multiple linear regression to predict the strategic pricing of new listed property on Airbnb. So if a new property comes in, what could be the right price to give? My objective. What is the right price to give when I have a huge record here, 74,000 records. So if I get a new record, what could be the right price? Now, going back to our Python file. I have imported the libraries. I'm putting the any error? No. Just importing it. So drop the columns that are useless for this model. So what are all the models that are useless in this model? What are all the variables that are not needed? ID is not at all needed, right? So to drop the variable, how do I use it? So here the data frame I have referred it as df, right? Df dot drop id. So do not forget to mention the access always. Access is equal to 1 and the df, or you can give it as in place is equal to 2. So the id value is deleted. So I have number of objects. It's nothing but the string values. These are all categorical variables. So what happens if you give the categorical variables to a regression model? How is it going to act? What is the workaround to give categorical variables to a regression model?
One-hot encoding.
One-hot encoding. The dummy variable creations. We have to create dummy variables for the categorical variables. So describe is equal to all. If I give include is equal to all, it is going to include all the categorical variables also. If it is a nominal data, you could use one-hot encoding. If it is an ordinal data, use a label encoding.
Okay.
Right? You know what is nominal and ordinal data, right?
Yeah, ordinal would be ranking, right?
Ordinal is a ranking, right? And the nominal is like pin code, the postal code,
yes,
or a name of a place.
Yes, sir.
Right? And here I get the summary for all the variables and the unique values for the categorical variables, right? So these all functions I had written and given this file to you. So the column in the data frame columns, so for what are all the objects, and just print. So this upper, what does this upper mean? Column dot upper.
Uppercase. All the it will print uppercase.
So yeah, perfect. Uppercase. For column, this is just in random name. In the columns, data frame dot data type, whatever it is equal to object. Print the column name, convert it to an uppercase. All right, and show me the unique values present. All right. In the second line, value counts for the we have 3 variables here: the shared room, private room, and the entire room and the apartment. You just sort it and show it to me in the ascending order, right? So that is what for all whatever the categorical variables present, you show me it in this way. So practically rental price depends on whether the property is instantly bookable or not when compared to. So this variable is not useful to us, so it can be dropped. So we are dropping one more variable, instant bookable. This true or not. So I do not want this. There are one more way how to find this is a good variable or not. So I'll tell it in the next session probably. So here I'm dropping one more variable, instant bookable. Whether the property is instantly bookable or not, this is not a right way. Right, instantly bookable by weather conditions or an external factor could influence this variable, instantly bookable. So that was the reason we have just removing this instantly bookable. Now converting this categorical variables to dummy variables. How do I convert this to dummy variables?
So pd dot get dummy.
pd.getDummies, right? In pandas it is present. pd.getDummies for the columns. So what all columns? For columns in df.columns, show me if df of column, just I'm showing me what are all the objects. D type is equal to object. Just print the column.
Equal to.
Thank you. So so only log price is present.
Columns.
Mm-hmm.
So df.columns.
df.columns, right? This is correct. For columns in data df.columns. Oh, did I convert it already? For columns in
column.
df.
It will be column. For column.
For column. Yeah. Sorry, my bad. So for column in df.columns. So since I use the same name, instead of I could have used x something. All right. So what are all the variables present right now? So the room type, the cancellation policy, and the cleaning fee. So the columns, columns, columns is equal to room type. Don't go slow. Let's not make any mistakes. Cancellation policy. Cancellation policy, comma, and what else is this? Cleaning fee. Cleaning fee. So I'm converting this all to dummies, and where am I saving it? Save it to the data frame, and let us check it out. So what happens to the room type? Room type 1, room type. So whenever it is entire room, it is 1. So if it is private room, this record does not. This has an entire room, so the rest all room type has become 0. The cancellation policy, since it is polycystic, rest all variables become 0. So cleaning fees is either true or false, 1 or 0. Right? Again, let me check. Is there any missing values? There are number of missing. Guys, do you have any doubt here? Creation of dummy variables. All right. Okay. So to check the missing values is null. Is there any missing values present in the data? If there are missing values, you just replace these values by the mean. How do I find? For the column in df.columns, df column, if it is not an object, I'm just creating mean is equal to df column, right? df.
Sir, why are we using mean? Why aren't we using median here?
You can use anything. It does is not a problem. Just for representation.
Okay.
Actually, when you start building the model, this mean, right? This is not in perfect measure. Even median is not in perfect measure.
Okay.
So there are various other ways to do the missing imputation of the missing values.
Okay.
Just for our understanding, just we are taking mean value. We have a regression to fill the missing values. We have a package called as mice, right? In the later sessions, we'll be seeing. We have a package called as mice. What it does is based on, we are taking mean is nothing but we are taking one single column and we are taking the average of all the variables and we are imputing that to the missing variable, right?
Yes, sir.
So what happens in regression is like, if there are 5 variables present, I take the regression of the 5 variables, I have the x and I have the y. For the missing values, I use that formula to impute the right missing value for that. So I don't want to confuse you here. So simple way what I'm trying to tell here is, so we have a formula, right? B0 plus B1 x1 plus B2 x2. So what does mice try to do if this variable is missing? We know rest all values. Instead of taking the mean or the median, considering the rest all independent variables, what could be the right missing value for that? That becomes more advanced predictive mean matching. There are various methods to do that, right? It takes some time to explain it, so I don't want to go into that right now, right? Monica, to just be clear, this is not a perfect measure.
Okay.
Just to impute the missing values, some impute missing values, and how my model performing. That's
Got
what, right? So df column, hope we don't make any mistakes. Df column dot fill na. Fill na is the function, and I fill it as the mean as the missing value. So I do not have any missing values over here. What did I do? Because for the variables, I used the mean to fill the missing values for the particular column, right? And I'm summarizing it, and I check for the duplicates, right? Is there any duplicate records present in the in my model, in the data frame? So I do not want to have the duplicates, right? So how do I remove the duplicates? So these are all hints. How do I remove the duplicates? Drop duplicates, right? So in place, again, in place is equal to true, right? Before and after. So we had so many number of duplicates. I'm just removing it. So I do not have any duplicates record here. So what is the correlation? So we see that the bedrooms and the accommodates have 0.71 correlation value, 71% correlated. Beds and the accommodates is 80% correlated. And beds and accommodates, I think we have discussed 80% correlated. Yeah. So these two variables are highly correlated, right? Since the beds are having highly positive correlation, one of these variables, I think beds had the highest correlation. So I want to remove this beds. Likewise, accommodates and bedrooms. Bedrooms and bed and bedrooms are also highly correlated. We want to remove some of the other variables, right? So I want to remove the beds and the bedrooms from this. Beds and bedrooms are highly correlated with this accommodates. Beds and bedrooms 0.71 and 0.8. I want to have the accommodates and I want to remove this beds and bedrooms from this model, right? This is again an intuitive way of doing it. We have one more advanced way to remove the collinear variables using the VAF value, right? That we'll possibly see it in the next session again, right? This is again, we are going by the intuition. Whatever we are going to use it, these are all basics. There are far more advanced way that we're using currently in the industry, right? For understanding what is in regression, to understand the inline concepts, we are just going where textbook concepts. Now we are dropping the highly correlated variables. So I want to drop again df drop. I want to remove beds and bedrooms. Access is equal to 1. In place is equal to true, right? Now I want to again have a heat map. We have the heat map, not many values are highly. Log price and the accommodates, let it be the price and the independent variable and independent variable, let it be highly correlated, right? Now I'm checking for the outliers. There are fewer outliers present, so I find the lower and upper range and I cap the outliers. You know what is in capping mean? Whatever the value is greater than this upper range, I cap it with this your upper range. Else you show me the same value df column. Alright. Now after capping, I do not see most of the outliers. Right? Do you have any doubt here, guys? How to cap an outlier? Vijay, Isma, Monica.
No, sir.
Okay.
No, sir.
Now check for the data distribution. I use an pair plot and okay. So we could see what is the distribution between the accommodates and bedrooms, bathrooms, and review score ratings and the accommodates, how the distributions are, right? Not many are linearly distributed over here. We do not find any review scores rating and the log price. Somewhat, I don't find any pattern over here. There are, do not find much of the pattern over here. Let's just again go ahead and execute the regression. Right, the train test split. I split the x and y variables. Right. So now split x and y. How do we do it?
Sklearn 10 test split.
sklearn, okay, that was all defined earlier. Df dot drop what? Oh,
It is already done.
okay. Now I just want into split it into x and y variables. So sorry, x train and x test and y train y test is equal to train test. Oh, why is the formula not coming? Okay. From sklearn dot model selection import train test split. Yeah, now it is coming. X comma y comma test size. Test size is equal to 0.25 comma random state. Test size is equal to 0.25 random state is equal to 1. Some random state you can give. I think by mistake I pressed an insert command. Right? Okay, no worries. So X trend interest, I'm just splitting it in the 75 and 25% ratio. Now a linear regression model. How do I execute the linear regression model right now? Let us go with the sklearn method. So using the sklearn method is nothing but a regression model. Regression model is equal to linear regression. Alright. So the linear regression, the regression model, I'm going to fit it regression model dot fit. Fit what? X train comma y train. Right, now the model is fit. Now I want to find what are all the coefficients, right? Regression model dot coefficient. So this is the coefficient. One second, I had a different for loop for this to show all the coefficients. So we could use this to display all the coefficient value. Let me just go back and right. So the coefficient for the accommodates is 0.11. So the coefficients of bathroom is 0.26. So what does it signify again? So what does this coefficient in the linear regression signify? Guys, am I audible? Vijay?
For 1 unit of change in X, the Y will change by 0.26 in case of bathroom.
Okay. What is the Y variable here? Here it is log price. We have taken the logarithm of the price. So 1 unit, 1 bathroom increase, 1 unit increase in bathroom. So 0.2646 unit change in the, it will increase by 0.2646 in the log price. The price increases by 0.2646. Right, this is the interpretation from this. Now, what is the intercept? The intercept value given by the regression model. Again, we have a variable called as intercept. Intercept we have 0. Okay, the intercept is 2.9173. Right, now the R squared. How do you find the R squared here? In the same model, the regression model. Regression model is the model name that I have built. I have the fitted data. In the fitted data, again, if I give score, so it has a variable intercept, it has coefficient, right? It has score, everything inbuilt. So in the score, X train, comma, Y train. So here it is giving me a value of 0.4877. So is it a good model or a bad model? So what is this 0.4877? Can you put it in terms and can you tell me?
Coefficient of determination.
Coefficient of determination. Just put it in some terms, some business report.
SSR divided by SST. Regression.
No, just business report. Something you want to explain to your management what it is. What is this? Yeah, that variation that you were telling me, right?
It explains the 48% of the total variance.
Yes, perfect. That's what I want. So 49% of variation in Y variable is nothing but the log price is explained by the predictors in this model. So overall, this 48.77 I mentioned there's 49%. The overall the 49% of the variation in the Y variable. The Y variable here is nothing but the log price. If you could go here, the log price is the Y variable. Is explained by the predictors. Predictors are nothing but all the X variables. The X the accommodates, bathrooms, cancellation policy, the clinic fee. These are all the predictors. 49% of the variation in the log price is explained by the predictors in this model. Is this a good model or a bad model?
Moderate. R square should be 1 to be a perfect model.
But it is more or less very less. It is a poor fitting model, right? You can check again how much the data is balanced and you can again go ahead with, but this is a poor fitting model. 0.48 is not a good model. What it means is there are some more variables to be imputed, or you just convert the rest all variables, take some scale and check whether all the assumptions are met before executing this model. Okay, I forgot to explain the important assumptions of the regression model. Once this is done, I'll just explain you what are all the assumptions for a regression model to be undergone, right? So there is some more important variable. If you could add, your R squared value may increase, right? Now regression model for the test data. Regression model, I'm using the same model and give the score for X test, Y test. What is the regression model score? 49.35%. Right, now we again regression model using stats model, right? Okay, that's okay. Let's go slow. I have 15 minutes more. I want to explain only one more concept. What are the assumptions of the regression? Using the stats model, what do I do? First, I do concatenate X and Y. PD dot concat. Using concat, I'm concatenating X train, comma Y train. All right, axis is equal to 1. I'm concatenating and I have to save it somewhere. I'm saving it as data train is equal to, right? So I'm saving it in the variable data train. So you could see here data train dot rename. This it becomes very hectic. So I just typed it before. So we convert this room type entire home type as room type entire home. Room type private room as this underscore was missing. Some error comes up, pops up. All right. So to mix it up, I just renamed all these variables. Renaming for simplicity. Sometimes the error, there will be error. The renaming is very much important for this stats model. All right. So what are all the columns that is present? So these are all the columns present. So in stats model, we always give it as a formula. Log price is y is a function of this tilde function is a function of all these independent variables. Y variable is a function of all these independent variables. Very important to note. Right now, build a linear regression using an OLS, ordinary least square. We call ordinary. All right. First, we have to import the libraries. Import stats model. Stats model. What was it called? Formula.api. Okay, as SMF. All right. Again, LM1. I'm just naming it as LM1. Any name that is just a name. SMF dot OLS formula. What is the formula? Formula I have given it as EXPR in the previous expression. Right, and the data underscore try. All right, then fit the data. Sorry, SMF. All right, so I did not execute this line. So my model from the library stats model formula API, I'm just executing this formula, the data fit. Very simple here. All right. Even if you have to run an R, it takes somewhat a few more steps to be done. Here it is very simple. Just take it, call the name, and use the command fit. Use the function fit. Fit it using the formula for this data. Now you run it print, and you know what is the R squared, you know what is the adjusted R squared, and you know what is the F statistic, and what is the probability value. Right? We find this log likelihood AAC. I said you, I'll explain it in the logistic regression session. So we know here again in adjusted R squared we could see 0.488. It is a very poor fitting model. Right? Now coming to the p-value. So which are all variables are more significant here? Which are all models are needed further building in the model? So which are all independent variables are contributing more to find the variation in y?
For which the p-value is 0.
So whichever p-value is less than 0.05. Right? So this room type entire room is not contributing to find the variation in the variable y. Right? And the cancellation policy flexible is not much contributing. In fact, the cancellation policy itself is not contributing. This cleaning fee is also not contributing much. So that was the reason this R squared is very less. Only this accommodates and the bathrooms and the review score ratings. These are the three variables, and again room type shared room. These are all the variables which are contributing to identify the variation present in the y variable. All right. So there could be some more hidden variables you just find out, and if you could impute or if you find an interaction term, that could be also of much use. Right now I'm identifying the MSE. So my MSE is mean squared error is 0.53. It's again a very high error. Right? Fine. You cannot tell anything. So this 0.53 is significantly more error. Right? Okay. 0.53 is a very high error. There's no doubt in it. Right? Now prediction on the test data. In the regression model, is to predict to what? X test. So I'm able to predict using this scatter plot. I'm just, so how much is it able to predict? Simply we have put what is the right prediction, right? So the actual and predicted, we have just plotted it, right? If I had pointed out few more conclusion pointers, if you could come down. Yeah. So the final conclusion, the final regression equation, the long price B0 plus B1 accommodates plus B2 bathrooms and B3 review scores and so on. And we have put the coefficient values for all the independent variables. So when accommodates increase by 1 unit, the log price increases by 0.1196 units. Please explain briefly these topics. Which one is Ma? Residual and fitted. I'll just explain you. I'll just go back again. I can explain you. Right. And when accommodates increases by 1 unit, log unit increases by so and so unit, keeping all other predictors constant. That is also very important to note. Keeping all other predictors constant. Similarly, when number of bathrooms increases by 1 unit, log price increases by so and so unit, keeping all other predictors constant. There are some negative coefficient values, for instance, right? The coefficient is minus 0.77. This implies when the room type is shared room, the log price decreases by so and so unit, keeping all other predictors constant. So if shared room is present, then the value of private room and the entire room will be 0. So likewise, in case of any other dummy variable. So higher the magnitude, most important the predictor variable, right? We determine the importance based on the p-value and the coefficient value. That's what I have put it in the conclusion. Now going back to the doubt that is asked by the residuals and the fitted is a very good question, and it is a very important question too. Right, before entering the residual and fitted, I'll tell you what that residual analysis, where it is leading up to. Right, the residual analysis, I'll just take my writing pad. So till date, we are using regression in our own office, and day in and day out, I cannot tell day in and day out, but still we are using regression when there is a use case coming up. Nobody have learned regression fully in our office too. So it takes a lot of time to learn the regression. Every time I execute in regression, there is some problem coming up. Right? The very important concept here is the residual analysis. Residual analysis, we give the residual analysis EI, the error term is given by YI minus YI cap. This is very important. This error, how is this error present? There, so going back, so how is the error comparing to the actual and predicted? Where is this error very much helpful? Right, now we have found the residuals. Right, now what are all the main assumptions? Where is this residual analysis helpful for us? That's what I wanted to tell you in the beginning, but somehow, anyway, it's okay. Assumptions. I'll give it as a short acronym. Line, LINE. L for linear, linearity. I for independence of error. N for normality. E for we call it as an equal variance or homoscedasticity. Skedasticity. Right? These 4 are very, very important assumptions There are a number of assumptions which was explained in your video, but out of which this 4 assumptions are very much important when you're trying to execute a regression. All right. So what is linearity? As that was covered in your video, what does that linearity mean?
There should be some correlation between the independent and dependent variable.
Independent and dependent variable. So what happens is, in the linearity, the residuals that we have taken it here, right? It should neither have a pattern. The residuals, I'm telling, the residuals should neither have a pattern, or it should not fall, something like that, or something like that, or something like this. It should never have a pattern. All right. So LANE, this linearity, so it may take you into more further confusions. So let me make it very simple. So the relationship between the variables are linear. I'll make it the x and y variables which are more linear. If you take into further more detail, what we have to take is, you have to take the residual values. If my x and y variables are more linear, the residual should not be linear. It should not have any pattern. That's it. Because all the variance should be explained by the linearity. Right? Or don't make this residual. That's the reason I do not want to touch this residual. It makes it into very much confusion. To make it simple, the x and y variables should be more linear. Right? Now, what is the independence of the errors? What does independence of errors mean? I'll again go to linearity if you want. I'm not able to frame it rightly. What is the independence of errors?
Every time we get one value of the error, that value should be constant.
Okay. Okay. So what is the equation of a linear regression, which I told you?
Y equal to max plus.
Y is equal to, if I want to mention it in the population, B naught plus BI XI. Can I mention? Is the formula full? Is the formula fulfilled?
Plus E.
For epsilon. What do we call it as? We call this as an error again. This error term is very much important, guys. So whenever we split the data which I told you, this becomes in panel data, and this becomes in time series data. This is in cross-sectional data. For example, if you take in company of an ITC, they have a number of products: oil, shampoo, soap, and let's take some beauty powder, something. And sales in the year 2010, sales in the year, different color, sales in the year 2011, sales in year 2012, sales in year 2013. This error term, or don't consider this error term right now. This sales in year 2010, sales in year 2011, will it be more or less same? Will it be linear? Or the sales in 2010, can we forecast the sales in 2011?
Yes.
So it is a dependent between the years. All right. So the variable becomes dependent between the time series. So for executing in regression data, it should be time independent. The error value should not be time dependent. If it is time dependent, we cannot execute it. That is a very important assumption for an regression. It should be time independent. So if you could refer it in some books, they will mention it as independence of error based on this epsilon I when we are collecting over the period of time. What does this independent of error means? this year sales and this year sales, we should not take the time series to execute this regression. When you have to take the time series, that is a different way of executing the time series data. We have to break the trend, seasonality, and cyclicality. We have these three concepts in time series. So when we go into the series of when we touch upon the concepts of time series, that module, where I'll tell you what is trend, seasonality, and cyclicality. That is where we are going to take the time series data. To execute a regression, do not consider in time series data. If it is time series data, it should be treated properly. How to treat it? We have to cancel. We have to write in linear regression equation, and we have to cancel out the time series terms, and it takes a sequence of steps, number of steps. So for right now, this independence of errors means this epsilon I, right? It should be independent of error. What does it mean? The previous year sales or this year sales, the time series data should not be taken to execute in linear regression. Let me come back again to this. Right now, you just forget it. Next, normality.
Bell-shaped curve.
So the data must be normally distributed, right? Whenever the data is not normally distributed, so there are various some other metrics, non-parametric tests to do execute in regression, right? That is not the scope of this session, or for example, for that matter, not the scope of your DSB course itself. If the data is not normal, we would forcefully convert it normal by taking log. That we have seen, right? The log, the square. There is some other concepts called as non-parametric tests. That is different altogether, right? When if the data is not normal, you have to convert it to be normal. If the data is not normal, then you cannot execute a linear regression. Next, the last concept is homoscedasticity. Homoscedasticity. I hope the spelling is right. Homoscedasticity. Okay, so it assumes the equal variance. Whatever the variables that you have taken, it's all constant. The variance is constant. The variance does not change. How do you check it? Using the Levin's test, right? Variance of what? Variance of this error epsilon I, right? So put it in the simple terms. The variability of y values is same as the variability of x. If y is high, the x should be high, right? So these four terms, linearity, independence of error, normality, and equal variance, I want you to do some homework, right? It cannot be understood like in 10 to 15 minutes of time, right? The data should be linear in the sense non-linear data, if you put it okay, to put it in simple terms like explained in the video, e power 0, it should be linear data. That is what should be considered for this model. The independence of errors, the time series data should not be taken. Normality, the distribution should be normal. Homoscedasticity, the homoscedasticity, it means the equal variances, right? We find the variance using the Levin's test, right? So much I could explain right now. I do not want to much confuse you. So instead of knowing all the assumptions, these four assumptions are very much important. So any doubt here? I certainly know there is a lot of doubt. You please do some homework. Again, we'll go to the logistic regression concept. The same assumptions of the regression will be touched upon. All right. So please do some homework on this LINE, linearity, independence of error, normality, and the equal variance. Why did I stress upon this error term is very, very important. It's like all the, when you write in this, whenever you write in regression equation, this error is very important. All the assumptions are based on the basis of this error epsilon. This error is a very important metric. Unexplainable comes to this error. Only based on this error, all these assumptions are validated. All right, I'm not supposed to explain all this concept. As a mentor, I'm only supposed to take the case study and I have to solve it out, right? So you people are completely blank on these assumptions. So please do some homework on these assumptions. All right. If you're not more clear, we'll again discuss it next week. All right.
Yes, sir.
Now going back to our case study and our learning objective. So were you clear on the concepts of what and simple linear regression and multiple linear regression?
Yes.
Using the case study, 2 case studies, and did this Excel also help you?
Yes, sir. It was very helpful.
All right. So what could I do? So you learned how to do B0 and B1 in Excel, the MSC, RMSC. How do you calculate the actual minus predicted, the average of all the squares? You calculate the MSC. All right, and you take the square root, it becomes the RMSC. And you calculated how to and you found how to calculate the MAP, mean absolute percentage errors. Important takeaway from this sessions are going to be only these things. You take these concepts, right, and forget this formula all. You may solve it or you may not solve it, but my kind advice is try to solve once and you forget it later. So you may remember the important concepts, how to calculate this B1, B0, how to calculate the MSC, RMSC. That is how you can convince your management or the client, right? You do something in Python, nobody is going to believe you. You can, if you do something, a formula, this is how I am able to predict for an experience of so and so, I'm able to predict the salary. Then you may be able to convince your management, right? So as a part of course, I did not learn this, but still, so since I wanted to convince my management, I took an extra step on how to solve this, and I have posted the same thing to the client and to the management, and then they were convinced, oh, this is how the regression works. So they were completely blind. You say something you are going to predict, and nobody is going to believe you. All right, and we have solved 2 case studies. All right, so Isma, so you raise a question, this residual and fitted plot. So what specifically you wanted to know about this residual and fitted plot? You mentioned about, explain briefly here. Was it brief enough, or what else did you want? All right, so I think I've taken the best to explain all the concepts, this linear and simple, the multiple linear regression. How did this 1 unit increase in the coefficient of X variable? How can you predict the Y variable? Right, that is the important takeaway here, right? And the correlation, one more important, if it is highly correlated, if it is multicollinear in nature, right, then you have to treat, you have to either drop the variables and then you have to execute the multiple linear regression, right? So any other doubt, guys? Vijay, Isma,
No, sir. Yeah.
Monica, please raise questions. So I tried my level best to explain whatever I have prepared. Sagar,
Sir,
Sandeep.
so could you please share that Excel sheet in which you explained that regression
Sure,
model?
sure, Sagar, sure.
Yeah.
Yes, Sagar.
So I'll go through it. Then I think it will be much more clearer.
Swagata.
Thank you, sir.
All right. So, okay. Adjusted R square you wanted to know. So how did I solve the adjusted R square? So, yeah. So if we go back to the Excel, the R squared and adjusted R square. So some statisticians used to tell like the R squared is not a perfect metric. When the number of independent variable increases, and you have to take the number of records also in consideration, right? So I take the degrees of freedom into account. Degrees of freedom is the number of records, M and C. In the ANOVA table, if you could remember, M and C, we have one variable, C and M. What is the M and C? So based on the degrees of freedom, based on the total records, I have total of 10 minus 2, it becomes 8. I'm sorry, I have taken total of 9 records. So I have one independent variable, M minus C, then it becomes N minus 1 is the degrees of freedom, right? Right? Again, the C is again 1, the degrees of freedom is, so if you could go back to the ANOVA classes and you could verify how to calculate these degrees of freedom, I think it will be more sensible, right? And sum of squared for the residual divided by the degrees of freedom, sum of squared for the total divided by the degrees of freedom. My objective is to find the regression. How much was my regression able to explain, right? Therefore, since I have taken the residual and the total, I have used 1 minus of the residual and the total. I will be able to find the adjusted R squared for the regression, right? So I think one second, give me just 2 minutes, guys. I'll just explain that. So in this plot, the regression explanation, regression sum of squared, and the unexplained variance, right? This unexplained is, I put it as the residual, this is the total, and this is the regression. All right, in this I want to find how much did the regression explain. That's what my R squared is trying to account, right? Considering the degrees of freedom, how much did the R squared explain? Just I'm considering the degrees of freedom into account. If I consider the degrees of freedom, how good did my model perform? Isma, is that clear or no? I think no. Okay, so if you're asked with an interview question, what is the difference between this multiple R squared, the R squared, and the adjusted R squared, right? In this linear regression, you come up with one more term, this multiple R squared. Multiple R squared is just nothing but the correlation between this X and Y. The R squared is nothing but how much did the regression explain divided by the total. The adjusted R squared is nothing but how much, accounting the degrees of freedom, how much did the regression explain. Right, we have one more column, this degrees of freedom. Accounting this degrees of freedom, how much did my R squared explain? Right, usually in simple it will not be making much of a sense. If you take multiple linear regression, then adjusted R squared is the apt metric to consider. Any other doubt, guys? So between, I have noted what is the perfect definition. So if any other doubt, guys, please stay, else we are done with this session.
Thank you, sir.
Yes. Any other doubt, guys? Yeah. Was my explanation clear enough? So this is what I wanted to perfectly take this session. I have prepared in such a way to take it in a planned approach.
In today's tutorial, we have learned about linear regression, and if you want to learn more about the advanced topics, then please go to Great Learning Academy platform, where you will get almost 80 plus free courses, and after complete your course, you can claim your certificate as well. That is also free of cost. Thank you so much to attend the tutorial.